In this lecture, we shall be considering the topic Law of Universal Gravitation. Let's get started. So the Newton law of universal gravitation states that every particle in the universe attracts every other particle with a force that is proportional to the product of their masses and inversely proportional to the square of their distances. Okay, so this Newton law of universal gravitation is represented mathematically by equation 1. So you can see the force of attraction between the masses, the particles. It could be heavenly bodies. Alright, so F equals to gm1 m2 all over r squared. So we have defined a mathematical equation here. So m1, m2 represents the masses and the unit should be in kilogram. Then r is the distance of separation of the two masses and the unit should be in meter. G is the gravitational constant and the unit is Newton meter square per kilogram square. So let's consider the first example that we have here. And the example says two 5.0 kilogram spherical balls are placed so that their centers are 50 centimeters apart. What is the magnitude of the gravitational force between the two balls? So the question is asking us to look for or solve for the force F, and we are being given two balls. So these are the masses, two balls. So the masses have the value of 5.0 kg for the first mass and then 5.0 kg for the second mass. Their distance of separation is given by the value here, 50 centimeters. So we have to go ahead, write down the mathematical expression, and then we substitute. Okay, so m1 is 5 kg, m2 is 5 kg. I had to write each, so meaning 5 and 5, one for m1 and the other one for m2. The distance is 50 centimeter, but I have already told you that the unit for the distance should be in meters. So we are going to convert from centimeter to meter by dividing by 100. So when we do that, we will get the value 0.50 in meters, or you can say 0.5 in meters. This one is a constant, G. So the value of G is given in this case. In a situation whereby G is not given, you should be able to recall it. Alright, so let's move on. So we are going to substitute the values we have into the equation and then we check what our solution would be. So this equation 1, I have done the substitution here. So the value, you see 6.67 times 10 to the power 11 is for G, and m1 here is 5, m2 here is 5, you can see it here. Alright, then our radius was 0.5, so you can see we had to substitute 0.5 square here. So when you simplify this, you will get 6.67 times 10 to the power minus 9 Newton. Let's go to the second example, but before then, if you are yet to subscribe to our channel, please do us a favor. I would like you to subscribe now. If you are a subscriber, please also endeavor to like, because when you like the video, other people can as well see it. Thank you. Let's consider the second example, example 2. Example 2 says, determine the force of attraction between the sun, and the value of the mass of the sun is given to be 1.99 times 10 to the power 30 kilogram, and the earth, and the mass of the earth is given to be 5.98 times 10 to the power 24 kilograms. So there is nothing to convert there. So now the question now says, assuming the sun is 1.50 times 10 to the power 8 kilometers from the earth. Okay, so we are asked to find the force of attraction, which is a direct question, and we are being given the mass of the sun and the mass of the earth, and the radius is given. Yes, the radius is given, but the constant g is not given. But you should know what the constant is, because it will still be the same value. Alright, so we are still going to use the expression F equals to gm1 m2 over r squared. Here we have decided to replace m1 and m2 with the mass of the earth and the mass of the sun. Whether you're writing the mass of the sun first before the mass of the earth, it will still give you the same answer. So the next thing I would do is to substitute. So for the value of g, I have substituted 6.67 times 10 to the power minus 11 times the mass of the earth, which is also here. Look at what I'm saying. So this is the mass of the earth, and this is the mass of the sun. Alright, so here where you have the denominator, we have r squared. So the r is the distance of separation. We also come here and then put the value of the distance of separation. But please note this, look at kilo here. Kilo is 1000. So we are going to include kilo here in this problem. Of course, if you multiply 3 by what I have here, is 10 to the power 8, this will increase to 11. Alright, so this would be 1.50 times 10 to the power 11. Then you close the bracket to power 2. Now, when you are multiplying the denominator or clearing the bracket in the denominator, you multiply these two by, you square this 1.5. Yes, square this 1.5, it will give you a value. It's just like saying 1.50 times 1.50, but you square it, it will give you a value. You write it down, times. You also come here and multiply 11 by 2. It will give you a value, and you write it down. So if I multiply 11 by 2 here, I will have 22 here. And let me calculate this. If I'm squaring this, that is 1.5 square, I will have 2.25. So this becomes 2.25. Alright, so for the numerator, everything on top you multiply it and then divide it by what you have here. where you have the denominator and then simplify, you will get the final answer to be 3.53 times 10 to the power 22. Thank you for watching and have a wonderful day.